All right, welcome everyone. You made it to the Mandalay Bay. So for folks who had trouble finding it, you made it. My name is Kevin Luo. I'm a principal product manager at AWS Identity, and I'm joined by...
I'm Luke Kennedy. I'm a principal engineer on the AWS IAM team.
Excellent. Now, before we get started, even though this is a 300 level section, I want to get a sense of who's in the room. And so, by show of hands, who's new to AWS? You're a new builder. Like in the last year or so. Okay, all right. Then are you an experienced builder? So you kind of know your way around. You can write IAM policies. Show of hands. Okay, great. And then how many of you can write IAM policies with your eyes closed? You just know them. Okay, we got one hand there, two hands. Luke? Well, Luke didn't raise his hand and he helped build IAM, right? I've been building on AWS for 10 years now, and even I get hung up on it. And so, today we're going to talk to you about IAM Policy Autopilot. It's a new tool we just launched that can help accelerate your workflows so that you can get started faster with IAM when you just want to build. So this is a code talk, so we're going to jump into a scenario here. So today we're going to build a microservice that creates and encrypts S3 buckets for a multi-tenant service. And this is really important because when I have a multi-tenant service and I onboard customers, I want to make sure that there's data isolation between that, right? And so I want to create a bucket just for that customer, and then I want to make sure I have a KMS key just for that customer's data. And so what we're going to do is when a new customer signs up, we'll create a dedicated KMS key for this customer, we're going to create a bucket, and then we're going to configure the bucket to use their KMS key. And so from an architecture perspective, it's going to be really simple. We'll have a Lambda function. It's going to accept a customer ID and name as a parameter. The first thing we're going to do is call KMS and create a key there. Then we'll create a bucket, and then we're going to call the encrypt bucket function. So with that, let's jump into the code. All right. So I have my IDE open here, and I'll walk you just folks really quickly through the code so you know what's going on. So here we have a Python-based Lambda function, and at the top I'm importing some of the clients that I'm going to need. So I'm using the Boto 3 SDK. And here you can see that we're accepting a customer ID and customer name as a parameter for the event. And the first thing we're going to do is we're going to check if the bucket exists, because I don't want to create multiple buckets for that same customer. And we're going to keep the code simple. There's a lot of things we could do to make this super robust, right? But we're going to keep the code simple here. And so I'm calling head bucket, and if it exists, then we'll just return early. Otherwise, we're going to go ahead and create a key, a KMS key, and we're doing a few different things here. We're also adding some tags, so it's easy for me to look it up later. I'm passing in a key policy, so to determine who can manage the key. I'm going to call create alias, just to make it easier to reference. And then now I'm going to go ahead and call create bucket. And the very last thing we need to do is call put bucket encryption to make sure that we're using the key we just created to encrypt all objects in that bucket. So fairly simple. And so if I'm getting started, right, let's just say I'm going to go create a Lambda function. So, I'll go to the Lambda console here, and we're going to create a function. We'll call this SEC351 demo. It's a Python function. And we're going to go create. And then while that's creating, we're just starting with the default execution rule here. We'll cover that in just a little second. All right. So I'm going to paste my code in. I'm going to deploy, and then what I'm going to do is create a test event so that we could see if it works. So, as we mentioned, we're going to create, it's going to accept a customer ID, a customer name. Let's do, I don't know, Acme123. Let's just name it and save it so it's easier for us to reference. And so we're going to test it. And of course, it fails, right? Because this Lambda function needs permissions. So here it's saying there was access denied when calling the create key operation because there's no KMS tag resource permissions. And so what does this mean? So if I go here and I look at an execution role, we could do a quick primer on what this means. So for those who are kind of newer to AWS, IAM stands for Identity and Access Management and controls who has access to what across everything, right? And so in this case, we have a Lambda function which needs an execution role, which is really just an IAM role. And then we're going to define IAM policies and attach them to that role to determine what this Lambda function has access to. And so in our case, we need this Lambda function to have explicit permissions to check if a bucket exists, create the KMS key, create the bucket, and then configure bucket encryption. And so if we go back here, then we can go and modify this execution role. All right, so, and this is it comes with some basic stuff, right? So this Lambda function has permissions to go to CloudWatch logs and create those logs so we could debug, and so we're going to attach here. And so now we're here at this screen. And so how many of us kind of just use administrator access here? I'll just expand this. Show of hands. It's okay. Be honest. You're just getting started. Nobody uses administrator access? Not for what? Not for a Lambda? Right. Because it's really broad. Well, when I got started for the first time, right, I'm like, hey, I want to just get this thing to work. And so I used to do this, and yeah, it's super broad, right? It allows star, but there's some benefits. If you're just, prototyping something, you're testing something, it has permissions to everything. So when I make an update, maybe I don't want to use, I want to use a different service, or I want to add DynamoDB to this. I don't want to constantly update my permissions. And so, this is nice in the sense that it reduces some work, but we have to always scope down earlier, and we all remember to do that. Okay. So then, what's the other option? So the other option is you can use some of the other AWS managed policies that are scoped down some more. So we use S3, and so I could look for S3 here. So how many folks use AWS managed policies as a starting point for these policies? Okay, I see about a third of the room, okay. And so AWS managed policies are a much better starting point. And so here, if I'm looking at S3, well, I know I need to create buckets, right? And so if I look at my options here, I have read-only access or full access. These other ones are related to different parts of S3. And so if I look at read-only access, well, I can't create a bucket. So then my only other option here is I could start with read-only and then add the specific permissions I need, right? But now I'm jumping in between things. Or maybe I start here. And so, okay, it's a better starting point. It's not the whole world, but it's still pretty broad and we have to scope it down. So let's just say for argument's sake, we use AWS managed policies. I just want to get started. So we'll do S3 full access, and then we use KMS. So I'm going to add the KMS managed policy that I have available here. And so we have it. All right. So now the function should work, right? So let's go. Let's go to the test tab. And it works. Uh-oh. So let's see what we have here. So we have an error message, and it says it's a malformed policy document exception when calling the create key operation. The new key policy will not allow you to update the key policy in the future. Who knows what happened here? What was that? Does anyone know the root cause? Right, okay, so then we gotta kind of, oh, you raise your hand?
I think we need to have a resource-based policy on that.
Need to have a resource-based policy on a key. Not quite, right? And so we have to kind of search around and figure this out. So I'll save you some time. It's because we're missing an IAM permission. So what we're doing is, if we go back to the code, when we call create key, we're passing in a policy. And so this is saying, hey, when I create this key, I want it to have this policy by default. But to do that, you need a KMS put key policy permission. And so what this error message is saying is it's warning you about a lockout. It's saying, hey, because I couldn't put this key policy, you're going to run into a situation where you're going to be locked out and you can't manage this key anymore. And so that's what this error message is saying. But if you're just getting started and you're not familiar, this can take a lot of time to debug. And so if I, just to show you, I'm going to go ahead and now I'm going to have to create an inline policy because what we're seeing here is that AWS managed policies don't necessarily have all the permissions you need. There's a lot of permissions out there. And so sometimes you have to add the ones you know. And so here I'm going to go to KMS, and this is about permissions management. So I'm going to add the put key policy, and I'm going to scope it, and we're going to click next. So put key policy. Okay, so now if I go back, we might need some time to propagate. Let's see what happened here. Let me just change this just in case, but I think it should work. Next, save. That's weird. All right, well, create alias. Okay, so it's because the key already exists. So let me just change the inputs here, so we're starting fresh. The specified bucket is invalid. What is going on? Is it too? Okay, yeah, I could zoom in. Specified bucket is invalid.
They have a space in your names.
I have a space?
I saw a space, but I wasn't sure. In the code.
In the code?
Sorry. No. Not the code, in the inputs, sorry. But it looks like you're right.
Yeah, that's weird. Well, for the sake of, this is how you know it's a real demo, folks. It's not scripted. Yeah, so just trust me, it kind of works there. And so, then, okay, what are the other options? So let's see, it's 2025, and we're all using coding assistants. I don't need to handwrite my policies anymore. I have coding assistants that do that for me. And so how many of us here use coding assistants? It's pretty much everyone, right? I love it. As a product manager, it's really great because it's allowed me to kind of get my ideas and build prototypes and kind of really interact with my engineering teams. And so, so that's been really great. And so now, okay, let's try using a coding assistant. And so I have my code here, and I have Kiro, and I'm gonna say, hey, generate an AWS IAM policy for my code. And so what is Kiro gonna do here? So it's gonna analyze my code, and it's gonna generate a policy. So it's reading this Python code. This file acts as restricted to a workspace attempted path. Oh, what's great? What is it doing? Okay. I think it figured out a different way to read it. So, so we have an IAM policy here, and it looks like it's got stuff. So let's take this, and then we're gonna go and modify that role. So I'm gonna delete the stuff we just added. And then we're gonna add an inline policy. And so I'm just gonna paste in what I have. And so this should, this is the Kiro generated policy. And here we see something interesting. So when you use the IAM console, it comes with policy validation built in, which is really great. So it tells us, hey, is all this stuff real, right? Or if I'm doing like an anti-pattern. And so we look at these error messages. What do we see here? It says, the action S3 head bucket, I'll zoom in a little bit more. The action S3 head bucket does not exist. And indeed, it does not exist. When you call head bucket, it's actually list bucket for the permission. This other one is interesting. Put bucket encryption. That seems like it should work. but actually the IAM action is put encryption configuration. And so if we think about why this is, right, why do coding assistants and LLMs tend to struggle with AWS IAM? You know, they're trained on public information like documentation, code examples, et cetera. And based on that, they learn patterns. And this is actually what humans do too. We learn patterns. Oh, I see the create key method call. So therefore, the IAM action is probably KMS create key. And that's a reasonable assumption to make most of the time. But then, you know, they don't understand things like hidden dependencies. So we talked a little bit earlier about create key, and I put a policy as a parameter. Oh, it also needs to put key policy action. Or there are these naming inconsistencies like put bucket encryption, that's the method call. But the action is put encryption configuration. And then it's not always the case that one method call requires only one IAM action. Sometimes it requires more than one. For example, S3 copy object. You need, you know, initially you might write, oh, the permission is S3 copy object, but it's actually two. You need get object and put object, which makes a lot of sense. And so if we recap our options here, you know, we have option one, which was administrator access. And for those who are really just kind of, hey, I'm just trying to blaze through, I'm in a sandbox environment, great. It's the fastest way to get started. And when I'm changing my code, I'm adding different services, I'm changing my mind, I don't need to touch my permissions again. It just works. But of course, we know this is super broad, it's powerful administrator permissions, and the security team wouldn't like that, right? But it's okay, I'm gonna scope this down later, and we all remember to do that. Okay, so then option two, we talked about AWS managed policies. And this is also fast if you know what you're looking for. You know what services you're using, you know if you're using read or write permissions, or you're using permissions that require permission updates. And this is definitely a better starting point than ****. Now, it comes with some trade-offs, right? When you're making code updates, you're adding new services or you're changing, like maybe I want to read from the S3 bucket now. Well, now you might need to change which AWS managed policies you use. And we also learned they don't necessarily cover all the possible permissions, like KMS but key policy here. And so these are great, it's a good starting point, but it's still broad. And we definitely all remember to scope this down. How many people actually go and scope down these policies if they write, for those who raise their hand on AWS managed policies? Do we go and scope that down later? I see a lot fewer hands. Don't worry, I won't tell the security teams. Okay, and so then we have option three, artisanal, handcrafted policies. And this is great. You know, it's closest to least privilege. Luke can write them with his eyes closed. But it's time consuming, if you're not like Luke and you didn't help build IAM, it's time consuming to research the exact permissions that you need. And again, we went through that kind of debugging flow there. And then also every single time, because it's least privilege, every single time you do something that requires additional permissions, you have to go back and modify these permissions. And so sometimes this can slow things down and you just want to build. Of course, LLMs solve that, right? It's fast. And a lot of times it does work until it doesn't. And then that continues to add to that debug cycle. Additionally, they're not always deterministic. They don't always generate the same policies. And that, you know, when it comes to access management, you really want some determinism there. And so I want to introduce you to something we just launched on Sunday, and we made open source. It's called IAM Policy Autopilot. It's a command line tool that can statically analyze your code and generate policies based on what your code is doing. We've also exposed it as an MCP server so that your coding assistants have access to the same deterministic policy generation capabilities. So let me talk a little bit about how it works. So step one, we use static code analysis to parse your code. And we do this all locally on your machine. And so here we have the Lambda function on the left, and we pick out all the SDK operations. Head bucket, create key, create alias, and so on. Then, the next step is we map these operations to IAM actions. So So one thing we do is we've actually published our IAM service reference available. So I have a URL here. If you type that in, you'll get a big JSON blob of all the IAM actions and conditions for all the different services. And this is great. This is a super helpful reference data. And recently, over the last month, we just launched an enhancement to this, and we added operations to actions mappings. And so here's just the JSON snippet here. And so what this does, it says, hey, we have this Boto3 create key operation. And it tells you what are all the actions that are associated with that. So here it's saying, okay, when I call create key from Boto3, I need the KMS create key action, the KMS put key policy action, and the tag resource action. Now, I don't always need them, but this is kind of like the outer boundary of what you might need when you typically call that. And this is based on actual service data that we have. And so now the last step is we combine that. So we got the method calls, we have our lookup, so now we can map out all the actions we need, and then we could generate a policy deterministically based on that. Now, I will say this policy is not a real one, right? I needed it to fit on one screen. But I'm trying to illustrate that, based on this, we can now generate a policy. And so there are 3 key benefits with this approach. The first is it's really deterministic. You give it the same code, and it generates the same actions and policies every single time. And that's really valuable when we want to think about access management. It's also up to date. It uses the live service reference data we publish. If we think about coding assistants, their training data was like last Thanksgiving, something like that. There are tools and stuff that can help keep it up to date. But here, we just launched a whole bunch of services that all those actions are now available in the service reference data. And so it has live, up-to-date information. And it's reliable. Because we're using this service reference data, you're not going to see S3 head bucket as an action that shows up here. It's all based on real stuff. Now, we're just getting started here, and I do want to call out some limitations that you should be aware of. So today, we just generate identity policies. And so we're not supporting kind of cross-account use cases where you might need a resource-based policy in another account to grant, access to an S3 bucket there. And these policies, as I touched on earlier, it's not necessarily going to be the most shrink-wrapped, least privileged ones, right? We do the action mapping here, and these are typically the actions associated with that method call. And so our intention here is to give you a better starting point than kind of some of these other broad options that we have. And when we looked at some internal data, right, we looked at the developers that, like actual policies that developers wrote, and we compared them to the number of permissions that IAM Policy Autopilot generated. And we found that it generated just 3% of the permissions of what's on live running code today. And so that's meaningful, right? What's out there is 97% overprivileged, even though we all have good intentions, right? The other thing is static analysis today doesn't support automatic identification of resource names. And so, you do want to scope your resources down to the specific ones, right? I don't want to just be able to read from every single S3 bucket in this account. And so you definitely want to scope that down. And depending on your journey and where you are, it could be something you do later or you want to do right in that moment. This is something that we definitely want to add coming soon. And then we have that action, operation to action mapping, and it generally catches the vast majority, but sometimes there are edge cases where certain complex cross-service dependencies might be missing there, right? I'll give you an example. Sometimes when you read from an S3 bucket and it's encrypted, you also need KMS permissions there, so there's some cross-service mappings. And so we're continuously adding to this. And so I've done enough talking now. Let's actually see it in action, so I'm going to pass the mic to Luke.
I'm going to take over, and we'll start by setting up IAM Policy Autopilot. So today we're going to use Kiro. And first we're going to get rid of this policy that we know is wrong. And we're going to get rid of this session, which gave us the wrong data. But first, we need to set up IAM Policy Autopilot. So we're going to pop over into our terminal. And IAM Policy Autopilot has a variety of ways that we distribute it, but the easiest one to get started with is just doing pip. So we'll just do a pip install of IAM Policy Autopilot. And it's that easy. So now I can just run IAM Policy Autopilot. And there it is. So as you can see, it does have functionality exposed here. But today we're going to focus mostly on the use case where you're using it with a coding assistant in your IDE. So the first step of that is setting it up as an MCP server. And every coding assistant you use is going to have a different method of configuring an MCP server. For Kiro, you click on the little ghosty icon, you come down to modify your MCP servers, and you get this nice little configuration. And we're just going to paste in IAM Policy Autopilot. Now, for those familiar with pip, you may be familiar with the UV tool, which allows you to run pip applications. I'm using UV in this case so I can get the nice update functionality that comes with it, so it will always update the pip installation every time I run the server. So I'm going to save this, and you can see over on the left that it connected, and it found all of my tools. So now IAM Policy Autopilot is available to Kiro as an agent it can use. So let's go back to our code. And nothing has changed here, but we're going to try to generate a new policy now. I'm going to get rid of that session, start over. So I'm going to ask Kiro once again to please create an IAM policy for this script. Now this is the fun part of the demo because this is the non-determinism that you get with any model-based thing. So we're going to hope that Kiro behaves today and plays to our script. So it starts, reads our file and says, you know, hey, I want to scope this appropriately, so tell me what region and what account ID you want to access. So we're going to use US West 2. And my account ID is also saved right here. And so it's chosen to call IAM Policy Autopilot. It's going to pass these parameters. You know, we're just going to vibe today and not really read those and just say run. All right, and it spits out this policy. And here's a short description. Would you like me to save this file? Yeah, sure. Please. And let's look at these permissions. So we'll start, we got these S3 permissions at the top. And most importantly, I don't see head bucket. I don't see any permissions that don't exist. It did give me the full closure permissions I may need for S3 based on the script. But I know they're all going to be correct and they're going to work. And here's my KMS permissions. You can see that the region is filled in, the account ID is filled in. The resources are wildcards because these are all create operations, and so we can't scope them to a specific thing. But now we have our policy. And so if I want to test out that policy, instead of going the long way, I'm going to use CloudFormation to do this. I encourage everyone to use some type of infrastructure as code setup to manage their entities across their account, and today I'm going to use CloudFormation, and Kiro's going to write it for me. Oh, I need to accept those changes. Okay. So now Kiro has everything it needs. It has the code. It knows that if it's going to make a Lambda, it needs to run that using an IAM role. So it's probably going to create that role too. Let's see what it spits out. All right. So here's my code. That's great. And here is my policy. And as we can see, it is exactly the same policy that we generated. It just took that in from the file and put it into here. Using CloudFormation, you can fill in variables and do substitutions for created resources. Our particular policy didn't have that because we're doing creates. But this is one of those cases where using something like infrastructure as code with IAM Policy Autopilot gives you a nice better together setup where it starts to least privilege down to the resources you need because it knows to fill in the variables at runtime and at creation time. So we have this now. We're going to ask it to deploy our template. All right, and go. Okay, so while that's running, we can talk a little bit about the CLI. So as Kevin mentioned, IAM Policy Autopilot does work as a CLI that also happens to have an MCP server endpoint exposed to it. When you use it as a CLI, it works just the same. So I can say IAM Policy Autopilot, and then let's do generate policies. And then I'm in the same directory, so we'll just say my customer onboarding. And I run that, and it immediately spits out that same policy. And let's make it a little easier to read for everyone so we can see it is, in fact, the same. And that's the determinism that you get from this tool, that it's always going to give you the same policy for your code. The CLI allows you to easily integrate this into other CI flows that you may have. So if you have a existing flow that takes your code and does some builds on it, we can now have that integrate with this and spit out your policies as you go. All right, let's go back to CloudFormation here. It says it's still running, but we can, oh, it says it just finished, but let's check on it just to be sure. Hey, it's good. Perfect, okay. So now we need to test that Lambda function to make sure it works. Because I've made these claims that we have the right permission. Let's enforce that, then back it up by saying, let's invoke this function. Okay, it's going to ask to run the Lambda. We're going to say run. You can see here in the terminal, it ran the CLI command, and status 200. And Kira wants to run it again for some reason. We don't know why, but we'll just tell it to stop. Okay, so that's great. I had some code. I ran it. It worked. It made a function that was good. But now let's say I want to iterate on this code. And I want to, instead of just creating the key, creating the bucket, I also want to get a notification that this is done because I want to do some further events on that. So let's add SQS as a notification queue. So I've got another script here. I'm going to pull over because I don't have time to type this. But here's the same script. I've added an SQS client. I've given it a queue URL. And down at the very end, after we create the bucket and put the KMS configuration on it, we now send a message to SQS to let us know that we just created all the infrastructure we needed for this new customer, and here's the basic identifiers we need for it. So from here, if we go back to our chat and say, please generate a CFN template for, if I can spell, apologies, for the current file, it's going to go through the same process again. It's going to create my template. Now, I didn't explicitly ask it to update the permissions on it. And so it's probably going to just pick up the IAM policy JSON it used here. And it'll wait for the agent to do its thing. Still going. Okay, unfortunately, Kira was very helpful and decided to add this permission. Let's unfix that. So we're going to come down here. We're going to just remove this. We all know that it's needed, but for the sake of the argument, let's say that Kira decided not to mess with our policy. Okay, and now please deploy. Let me go through again with the new change set.
While it's running here, so in this case, Kiro did add the right permissions. And we did probably this dry run, I don't know, 10 times, Luke?
At least 24 times.
And on, going back to that non-determinism, it did it some of the time, but a lot of times it didn't. So, you're kind of coming down to chance on this. So here we're going to simulate an example of what happens if it didn't add that permission, or sometimes ourselves, we're all humans too, right? And sometimes we deploy something, we're like, oh, I forgot to update the execution rule. And so now we can see, IAM Policy Autopilot includes additional functionality to help you with this as well.
So we see a case where cloud formation's just
Taking its time.
taking its time, it's kind of stuck. I have a feeling that stack will never finish, so we're just gonna try, we'll try again from a different template.
We're doing a little bit of a cooking show. Anyone watch that? You pull it from the oven. All right.
Okay, so here we go. It's deploying. And we know this is going to break. So we know that it's going to create the template, it's going to create an IAM user, it's going to create an IAM role. That role is not going to have the required SQS permissions. That's intended. So we're going to execute the Lambda function. Now, we already deployed that. Okay, so let's run that function. Okay, and we can see there is an error here. Whoops. And that error is the KMS key already exists. Let's try a different input. Okay, so now we're using customer bouncy pancake. And okay, look, we got a message saying, as we expected, we do not have permission to do this thing. So this is where IAM Policy Autopilot has additional functionality that we can look at these messages and say, hey, you don't have permission to do this thing, why don't you fix that for me? And this is how we can do a full agentic flow with this. By having the ability to analyze, hey, I got an error, can you go fix it for me? And it chose instead to modify the template. So let's try this again. Okay, now it realizes, hey, I have a tool to fix these errors, so let's try running that. And this tool allows us to look at an access denied message and say, hey, I know what this resource is, I know what this principle is, I can generate a policy that's going to fix this and put all the necessary permissions in. This is a simple case because it's just SQS send message, but if it was a more complex case where it had dependent actions, IAM Policy Autopilot would also add those. So now I'm going to tell it to deploy it to my account. It's going to invoke a tool that I apparently just trusted all the way. And so now it is deployed in a policy on my account to give me those additional permissions. And so it wants to test the function again. We can say run. Let's get to the bottom here. And we can see, oh, now it passed. And there's our valid response coming out of Lambda.
It might be important to talk about why this is really useful. So here we have kind of like a one-off instance. But with these agents, you want them to go run off by themselves. I want to say, hey, go complete this task for me. And I'm going to go walk away, grab a cup of coffee, and then come back. And so with this, it's easy enough for a human to go, hey, okay, this error message, I need to add this missing thing. But if I'm walking away, I'm not supervising it. I want my coding assistant in Kiro to be able to do that myself. And so now it has the tools to be able to do that. And let's say sometimes you have layered access denied errors, right? You have one that shows up, you fix it, you run it, another one shows up. And so for humans, it's kind of tedious. But now, by exposing this as a tool, this coding assistant can go and unstuck itself. And so that's kind of the power and why we expose this capability as one of the tools. Okay, cool. So I'm going to do a quick recap here. So we showed you how to use IAM Policy Autopilot to generate policies from your code. And we showed it that when you combine it with a coding assistant and define things as infrastructure as code, it can do things like do the variable substitution for scoping down by resources. And so there's a really great better together story. We also talked to you a little bit about that fixed access denied workflow, right? And so this empowers your coding assistant to get itself unstuck, right? It's the same tools that we ourselves would do if we looked at the access denied error. And we did this all without broad permissions like administrator access or AWS managed policies or just S3 star even. And it was deterministic. It only used real IAM actions and services. And it's up to date. Now, we're just getting started. So we're only supporting identity policies today. And it's not guaranteed to be least privilege, right? So there's still some scoping down. But now you have a much better starting point. We talked a little bit about how Policy Autopilot generates 3% of the permissions that kind of developer policies are today. And then we're working on adding in the static analysis support to automatically identify your resources, so it will just only get better over time. And so I have a call to action here. We've open sourced this for a reason. We want to collect your feedback. We want to do the development in the open. And so please, go visit the GitHub repository, clone it. We built it in Rust, which we love very much. And if you have feedback or if you have questions, feel free to engage with us there. We're always planning to improve it and keep on the lookout for that. All right. So with that, I have my obligatory thank you. Luke and I will hang out here if you have some one-on-one questions, so happy to take them, or we can do a group discussion here up front. Otherwise, this is your reminder to please complete the survey in the mobile app.